Hello and welcome to the course on Vehicle Dynamics and Control at the University of Lübeck. My name is Georg Schildbach and I'm a professor of mechatronics at the Institute of Electrical Engineering in Medicine at the University of Lübeck. Before we get started with the actual contents of this course, this video contains some information about the organizational details and the topics covered in this course. The official name of the course is Vehicle Dynamics and Control, and the official number in the University of Lübeck's internal system is RO 5500. The course consists of 2 hours of lecture per week and 2 hours of exercises, and it yields in total 4 credit points. The course is officially an elective subject in the Master on Robotics and Autonomous Systems. However, it's also frequently taken by students from other study programs. If you're not sure whether this course is accepted in your study program, please feel free to come up and talk to me. Within the Master on Robotics and Autonomous Systems, the course can be either taken as a standalone course or as part of the module called Autonomous Vehicles, which carries the same module number RO 5500 as the course itself. This module can either comprise 8 credit points when the Vehicle Dynamics and Control course is combined with the course on Perception of Autonomous Vehicles, which is given in the winter semester, or the module can even be a 12 credit point course if, in addition to the Perception of Autonomous Vehicles lecture, you also take the seminar on autonomous vehicles, which is given in the summer semester. As opposed to this lecture on the Perception of Autonomous Vehicles, which is mostly concerned with the sensory side of vehicles, this module covers the actuator side of vehicles, and in particular, the fundamentals of vehicle dynamics and control. The goal of this course is to equip you with a fundamental understanding of the dynamics of a vehicle, as well as the most essential control systems in a vehicle, which includes the basic terminology and most essential concepts of this field, as well as a basic understanding of all relevant vehicle components. The main idea is that after taking this course, you should be able to start working at the current research level in either an industry position or an academic position. Necessary prerequisites for taking this course are, first of all, a basic course in mechanics, such as the one with the number RO 1500 at the University of Lübeck, and a basic course in control systems, such as the one with the number RO 4400 at the University of Lübeck. Moreover, what you will need is some basic programming skills in MATLAB and Simulink, which are used for the exercises. In order to successfully complete the course or the module RO 5500, besides taking part in the lecture and exercises, you need to pass a written exam after the end of this semester. This examination can then either count towards the module RO 5500 KP08, for which you also need to pass the exam on the perception of autonomous vehicles, or towards the module RO 5500 KP12, for which you additionally need to also pass the seminar, or you can take it as a single course with 4 credit points. Next, we have some further details about the time and the venue of the lectures and the exercises. First, the lectures officially take place on Tuesdays from 10:15 a.m. to 11:50 a.m. However, these lectures take place digitally, so they're given in the form of YouTube videos, which you can watch on your own and hence asynchronously. The exercise sessions, on the other hand, are synchronous and take place every Friday from 9 a.m. to 10 a.m. The idea is that we use these exercise sessions for the discussions of any questions about the lecture material and also for an explanation of the exercise tasks and some solutions. Please note that there's a Moodle website for this course, and it's important to register for the Moodle course because all announcements, lecture materials, exercise sheets, and so on will be made available via the Moodle page. Now, here's some further details about the lecture. The lectures will be given by me, and they will be predominantly based on YouTube videos. Moreover, for certain topics, there will be some additional handouts. The focus of the lecture is to teach you the fundamental concepts, meaning the fundamental terminology, the mechanical modeling, and the basics of control design for vehicles, which you will then use in the exercises to solve particular tasks. Should you be looking for additional references about the contents of this course, there are in fact many helpful textbooks and lecture notes available on this subject, such as the ones listed down here. However, you should note that this course is not built on a single textbook, but rather it selectively assembles different topics from these references and also other sources. The exercises for this course will be covered by our teaching assistant, Mariam Nizami, and in total there will be 6 bi-weekly exercise sheets with mandatory hand-ins, which means for each exercise sheet there will be a hand-in date and you should submit your solutions via Moodle to Mariam. The exercises themselves are designed to get you familiar with the basic concepts and also will have a strong focus on practical implementations in the form of simulation models in MATLAB and Simulink, where you can also do control design. The exercises themselves will be in an office hour style, meaning that it's kind of an open discussion of problem statements. There will be answers to questions that you might have, and there will also be an explanation of the solutions of the previous exercise sheets. The exercise sheets will be made available in Moodle ahead of time, and ideally you should try to work on these exercise sheets in small groups, because discussions not only help you to save time by preventing you from getting stuck in certain situations, but also they help you to get a better understanding of the material if you talk with others about it. On the final slide of this introduction, you find a brief syllabus of this course together with a tentative weekly schedule over the entire semester. The chapters to be covered in this course after the organizational matter, which was the subject of this video, are as follows. Chapter 1 is on the kinematic bicycle model. Chapter 2 is on the dynamic bicycle model. Chapter 3 is on vehicle handling performance. Chapter 4 is on longitudinal vehicle dynamics. Chapter 5 is on the vehicle performance limits. Chapter 6 is on automotive suspensions. And Chapter 7 is on path planning for automated driving. And finally, the last chapter contains a practical case study.